Well, hello everyone. My name is Eric Calderup. I'm a member of the ABIPS-USA Education Committee, and I'm pleased to welcome you to this webinar. Got a few quick announcements for you before we get started. Please be aware that this webinar is being recorded, and we plan to have time for questions at the end, but please use the chat feature to type in your questions, and we may be able to get to some during the session. If you are an AIA member and you wish to receive AIA credits, please send an email with your member number to info@ebaia.org, and we will have a, we'll also paste that in the chat. And then finally, for the ABIPS-USA members in attendance, thank you for being a member. If you are not an ABIPS-USA member yet, then please consider becoming a member. Go to ibpsa.us and you'll find the information there. I also want to take a minute before we get started to thank the sponsor of today's webinar, Oliver Baumann of Baumann Consulting, and invite him to give a quick message.
Thank you, Eric, and good morning, good afternoon, good evening, everyone, wherever you are. Today's program is really interesting to me. When I started energy modeling almost 30 years ago, it was all about scripting and coding. I wrote my deck files in a Word editor and converted them into Transys simulations. And then I used Excel macros to deal with the data that I got out. Today, Baumann Consulting leverages Python scripting to speed up repetitive tasks, perform parametric energy model studies. We run urban scale analysis, quality control, our simulation output, and really unlocks software features that are only available via API. We believe that the time savings, improved quality, and process efficiencies gained by incorporating scripting into simulation workflows are essential to making high-performance buildings the industry standard. One of our firm's core missions is to support research and development opportunities that drive innovation and technology transfer in the energy-efficient building sector. So supporting today's webinar was a no-brainer for us. Look forward to a great presentation. Thank you.
Thank you, Oliver. And now it's my pleasure to present today's speaker. So today's presenter is Clayton Miller, who is an assistant professor at the National University of Singapore in the School of Design and Environment. He'll speak today on the topic of Python programming for energy modelers. And Professor Miller is very well traveled. He's studied architectural engineering at the University of Nebraska, followed by a master's degree at the National University of Singapore and a Doctor of Sciences degree from ETH Zurich in Switzerland. He is also well known for teaching a popular edX course called Data Science for Construction, Architecture, and Engineering. So maybe you'll want to check that out too. And he's joining us very late at night, so I appreciate Clayton's willingness to talk to us, and please take it away.
Yeah, no problem. Thanks, Eric. And thanks to Baumann Consulting, and thanks to Oliver for that introduction of our sponsor. It's really cool to hear others have similar sort of scripting histories, and you'll hear a bit about my background and motivations for learning to code all these years. So first off, I put in the chat a link where you can download these slides. Almost every slide has a link on each slide, which references the material for that slide. So you can download that PDF and click on those links and kind of follow along as we go. You can also scan this QR code on your phone and follow along as well. Just to get started, I want to introduce myself and my team. We're part of the Building and Urban Data Science Lab here at the National University of Singapore. We're a very interdisciplinary team with architects, engineers, computer science, hardware and software experts, all different kinds of experiences working together to improve energy efficiency and comfort and safety, satisfaction, et cetera, in buildings. You can check out our website if you're interested. And also, if you're not familiar with the National University of Singapore, we're now in what's called the Department of the Built Environment, which is a new name change as of a couple of weeks ago. And we're ranked amongst the top built environment programs. We have a sister department here, Department of Architecture, Department of Built Environment. We're kind of more on the technical side, kind of like architectural engineering, which is pretty common in the States, as well as built environment. So yeah, as was mentioned, today we're going to talk about, I think, a really popular topic, Python and coding. And what I'm looking for today, I think the abstract that you might have seen kind of had some promises of going into maybe some details of loading data and doing things like that. And we just don't simply have enough time to do that, to cover in a lot of detail different areas of using Python. However, really, I mean, we're going to use this hour today, and I'm going to have about 40 minutes of presentation, so we have enough time for Q&A at the end. First goal is really to convince you that learning to code, is Python being one example of learning to code, is useful. It's easy to get started with. It's going to make an impact if you invest that time. And then number two, show you different paths to go down to learn if you're interested. And it's never been basically easier to kind of get started learning in this path. So hopefully very practical advice, but nothing in too much detail. And that's probably also a good thing. Some of you are just waking up. I'm at the end of my day, almost midnight here. So nothing, want to keep everything kind of light and fun and motivating in a sense. But first, before we dive into that, I want to talk about what's wrong with the building and construction industry. What are some of the reasons that we should learn new skills or really transform the way we do things? And the first one is, this is a few screenshots from around the internet that I took a few years ago. There's really an explosion of data occurring in the built environment. Here you see lots of sensor data, sort of vendors that are talking about IoT and these type of things. You could also add in here simulated data, that there's a huge growth and creating not just one model for a building but multiple models, or even hundreds or thousands of models, as well as spatial data. So since 10-15 years or more, building information modeling has become mainstream. We're starting more and more to use these BIM models to create building energy models, building performance models. And so there's just a rich amount of these spatial data and spatial data with attributes, with informational attributes attached to it. But in the last 10-15 years, where has these data, where have they gotten us? And I think that there's a really interesting article. If you've seen any of my presentations in the last 3 years, you've probably seen me talk about this article. It's really all about the construction industry, at least in the United States, and how most other fields, kind of as they get larger, they reach these economies of scale and they reach more efficiencies and things like that. But the building and construction industry, if you look at the graph on the left in this Economist article, has actually peaked in the late 60s in terms of efficiency, in terms of value created per hour worked. And there's a funny quote in there, we're all using, well, everyone else is using iPhones, we're still using Walkmans in the construction industry. I always love using this slide with my students because they have no idea what a Walkman is. Maybe some of you out there do. It's basically a cassette player. It's kind of the old version of mobile phones or smartphones, I would say. But so anyway, the point is that construction, despite the fact that we've created more and more data sources, it's not necessarily increasing the efficiency of things in the same way that agriculture, retail, and manufacturing, these are all things that are having huge increases, while we're sort of stagnant and even going down in some situations. And some people might even argue that the increase in data could be part of that problem, is that there's just an overwhelming amount of data, and it's easy for architects or building owners to maybe change their minds and things like that. So It's really, there's some potential here for improvement. And since like the last 15 years that I've been in the industry, I've spent a lot of time talking to different industry stakeholders. And here you see a whole smattering of logos of different organizations in Singapore, in the US, Europe. And I've talked to or done research or collaborated with each of these entities. And really there are key takeaways from, in general, from all of those interactions that we have tons of data, crap loads of data. We have building information models, energy models, construction management, BMS, EMS. We have all these data being created, and generally these data are not being used much more than just the very basic reason that that the data was created. And down at the bottom, and another big thing that I realized is there's a huge lack of understanding of how to even use these data outside of their original uses. So, using a BIM model or using an energy model in the construction or operations phase, there's really not a lot of awareness of maybe even how that could work in a lot of the big companies, at least. So really, how can we improve this? How can we utilize and leverage these data sources? Well, as a community, as a professional community, we need to be more sort of data literate in a sense. So really, how do we better leverage building performance data? So right out there are three kind of categories of options. And this is a kind of an analogy I just came up with in the last few weeks that I'm just preparing for this presentation. You have old school spreadsheets. You've got sort of these tools, next generation tools, Power BI, Tableau, you have Python and other languages. So which one do you focus on? Well, let's look at an analogy, and no analogy is perfect, but let's see how this one goes. How do we nourish ourselves? How do we feed ourselves? How do we create or make food for ourselves and our families? Well, the first way is that you could make yourself a PB&J, peanut butter jelly sandwich. Maybe you could order some fast food. Anyone can really do this. It doesn't take a lot of skill to just make a sandwich or order food. But you don't want to do it so often. It's not a very healthy lifestyle to only live off of PB&Js, although a lot of college students might be doing that, but it's not healthy. And it's usually only limited to certain situations where you need something fast or something like that. The analogy I'm trying to make is that spreadsheets are kind of like that. Everyone knows how to use them. They're really easy. You can instantly get value. But I think it's basically unhealthy. I use the word unhealthy to use them exclusively. And I was in that seat 10, 15 years ago where I only use spreadsheets. And a lot of people in here are engineers. We love using spreadsheets. But there's a limitation. There's a lot of limitations to spreadsheets. You'll go insane if you use them for really big data sets, especially time series, or if you want to try to do more advanced techniques like clustering, machine learning, and other things that I'll talk about today. So what about some other options? Well, let's go back to the food analogy. Well, you could order from your favorite restaurant. You could, get takeaway. You'll get a relatively fast meal prepared by an expert. It could be nutritious. It could be tasty. So it's obviously a lot better than a peanut butter and jelly sandwich, but it may not be sustainable financially. It may cost you a bit more money. Obviously, it's expensive to go out to eat every single meal. And the options that you have available will have limitations. So you'll only have certain restaurants you can go to, certain things you can order. If you have any sort of dietary restrictions or certain tastes, you're going to have limitations no matter where you are. So in the data analytics community, I see an analogy with tools out there. So there are really nice tools where you can really take spreadsheets above and beyond spreadsheets to process data, to visualize data, and do lots of things that in an easier way than using spreadsheets. But once again, they lack the flexibility and capability to meet every need. Let's say you maybe have to fit your analysis questions into the options that these tools have, and they may cost money. So you may have licensing and subscription fees and things like that. So it may or may not be sustainable. So last stop here in this analogy is the option for when you want food, you learn how to cook. So you learn how to make tasty and nutritious food yourself. You'll have, exactly potentially the meals the way you like them, meeting your needs, meeting your budget. But there's a lot more nuance. There's a lot more effort to developing cooking skills, as we all know. And there's there's a range of passion that comes behind learning how to cook. There's a range of background and experience and family and friends and all the different things that go into developing cooking skills. So that's the analogy that I'd like to make today with Python, is that learning to cook is like learning to code. You have a lot more control. You can, really from the ground up, develop your visualizations, your analysis, but it's a process that takes more skill, more effort, and more passion. In a sense, you have to really stay motivated, and the learning curve is different than the previous options that I mentioned. So just like food, nobody usually only does one option. So it's usually a combination. You make sometimes sandwiches, sometimes you go out to eat, sometimes you cook for yourself or your family. And I think that's the same way with using spreadsheets, using more advanced visualization tools, and using something like Python, is that it just depends on the situation, depends on your budget. And most people use all three. I use spreadsheets and Python. I don't use the tools so often, but I know a lot of people do. And which one you choose in terms of making food also reflects your skills, the skills of those around you, and your own personal motivation and passions. So as I'll talk about here in a second, I've taught a lot of Python to a lot of people over the last 4 years. And it's usually, there's kind of a breakdown between a certain percentage of people really loving it, certain percentage of people being like, oh, this is okay, and a certain percentage of people who just kind of hate it because it's different and it's hard. So I'll talk about that also as we go through this. That's really the next slide. So as I mentioned, since 2018, when I joined the faculty here at NUS, I've been teaching undergraduates in a class called Digital Construction. And so over 600 of these students have gone through my course. These are project and facilities management students. These are not engineers, they're not computer science students. These are basically 18 to 22-year-old freshmen that are learning Python. And so there's various, like I said, various lessons that come through, but the biggest lesson for me is that it's possible, and people can pick it up once they see the value and the usefulness, which I'll talk about today, as well as there's also some master students as well that went through the program teaching Python. And then, of course, as was mentioned, there's also an online course. So I've seen over the last 10 years, I've basically given workshops at ABIPSA conferences off and on over the last 10 years. And I really saw a lot of people wanting and needing this type of instruction. So I created a course, which started last April of 2020. The current next launch is in August. So if you're interested, please check it out. It goes through all the different types of technologies that I'll talk about today. It's a starting point. Once again, it's not a course where you're going to come out the other side and be a professional Python programmer, but it will get you started. And the most beneficial thing, I think, is that it is grounded in the context of the built environment. So it talks about building related data sets, the phases of the building lifecycle, design, construction, and operations. So it's hopefully something, and I have seen from the feedback that it is something that helps motivate people to see these skills taught in the context they may care about. And yeah, as I said, what I tell my students is, and I would say 40% of my role in teaching Python to my students is to motivate them and tell them why they're doing it, because I think that's the most important. Most of their learning doesn't come from me. It comes from them applying the skills to data sets that they care about in the future. And so I try to just motivate them. And I tell them, I'm teaching you to code. So you have the skills to do two big things: automate processes, work with large data sets. And these skills will help future-proof you in the building industry or any industry that you decide to go into. So let's dive. Now that I've kind of hopefully gotten you fired up about this is a good thing to do, let me talk about some of the key tools, libraries, components within the Python programming language. I won't spend a ton of time talking about, what is a variable, what is a, operator and things like that, because those are the details that you would get into when you start tackling Python as a language. But I will talk about the libraries of Python that really make it very useful for built environment professionals. The first library, and just to explain what a library is, Python is a base programming language you can use for basically anything. You can build websites, you can do data analysis, there's loads of things you can do. But it has all these little libraries of functions, and each of these libraries has specific uses. So the first library I'll talk about is the Pandas library. This came out of, was invented basically from the finance industry, where they're using it to look at like stock data and finance data that has time series, like timestamps. And this probably started, I guess, 10 or 15 years ago. And since then, it's really become the #1 data science tool for Python. It's really made Python into something that is comparable to MATLAB and R and these other languages that are out there. So Pandas basically creates a library of data containers that you can put in, one of them called a data frame, which is going to be similar to a spreadsheet in a way, 2 dimensions. And you can apply various functions to that data frame to slice it and resample it and do all kinds of what's called processing or munging. So if you check out any of the stuff that I have online, especially my course, I spend a ton of time talking about the Pandas library because it's super, super important. The second library I'll bring up is the Seaborn Data Visualization Library. And this is a library that gives you a really rich toolkit to visualize data. And you can check out the link and you can look around. Seaborn is one of, I would say, 5 or 6 different visualization libraries that are popular in Panda or in Python. I use it quite a bit because it's kind of more research driven. There's more statistical based visualizations, but there's also other libraries called like Plotly. There's Matplotlib, which is kind of the foundation. And there's a whole bunch of different options out there, which really give you the tools to visualize data in lots of different ways. Diving now into the little more advanced libraries, sci-kit Learn. This is your machine learning library. This is where you learn how to classify, regress, or cluster data. It's really a very broad toolkit of all different kinds of models out there. And really, this is where we dive into like the fact that, you know, learning Python or R or any of these languages, you're really opening up the use of these type of toolkits, which is really beyond what you would find I think in Power BI, definitely within Excel, is to do these type of deeper techniques. And then here's a slide which is just trying to catch all of, you know, this is just a few, but there's really literally thousands of other Python libraries out there that can really, you know, focus on any type of data processing you can possibly think of. There's a lot of computer vision, image recognition. There's database related Python libraries. There's network graph models. As you'll see in a second, I'll also go through building simulation related libraries that are out there to kind of dive closer to this field of simulation that we're going to talk about later. Beyond libraries, there's a couple technologies I want to bring up, which have also revolutionized the use of Python especially for beginners. One of them is the Jupyter project. Jupyter is an open source project, which really is what's called a integrated, it's like an IDE and a development environment in a sense, that's in the form of what's called a notebook. And you can see a few little examples here. I also have some examples later. A notebook it's like a report it's a web-based report that has both code in it. So Python code, little snippets of Python code that are meant to be executed one chunk at a time. So a user can actually see exactly like, what does this 3 lines of code do? Okay, that's the output. What is the next 3 lines of code? As well as text which explains what's happening. So it's almost like a report in a sense. You can actually say, you know, this is a model calibration process. Step 1 is this, step 2 is this. So it's really powerful for beginners. It's great for communicating a process of analysis. This is also a big benefit as compared to spreadsheets, where you can actually show somebody, you can send them a raw data file, you can send them a Jupyter notebook, and they can see step by step how you got from raw data to finished, analysis. That's not something you can do in spreadsheets, right? You can't just send, people have to reverse engineer what you did and all that kind of stuff. So reproducibility is also a really crucial factor. The next thing I want to mention is Kaggle. Kaggle is a platform that uses Jupyter notebooks as a means of creating basically this huge environment for people to create and share public notebooks and data sets. Kaggle, if you're familiar already, they do a lot of machine learning competitions. But in the last 2 years, especially the last 1 year, they've focused more on creating this sort of sandbox environment where people can create different types of analysis and what I call recipes to go along with my cooking analogy. And we'll talk about that in a second. But really, there's loads and loads of stuff on Kaggle that helps a beginner get started. And like I said, I will talk about that more later in the context of buildings. So in this next section, I want to go over, lots of different paths specifically for building energy modeling. So hopefully by the end of this section, whatever tool you use for simulation, you would have maybe seen in this list and been inspired to go down that path. So Python for blank and the energy modeling communities. So the first one I want to talk about, Energy Plus, of course, the kind of the mainstay sort of simulation engine from the Department of Energy that a lot of people use and a lot of other programs use as a core engine, recently came out with a Python API. And I had the pleasure of having a call with Edwin Lee, who's a researcher from NREL, and who's kind of one of the drivers behind this API. And he showed me some really cool demos, basically, that show how basically using Python script, you can kind of interact with the Energy Plus engine during the simulation timestamps within the engine. So creating these like mashups of the engine and creating these couplings and all these things. There's all kinds of really cool opportunities to use this API for. For those of you that don't want to go that deep, there are also other libraries out there that help really just process IDF files as an input and post-process data coming out of Energy Plus. And there's lots of examples of that on the web as well. OpenStudio, some of you might use OpenStudio. They also recently announced that they're supporting Python as one of the languages that you can use to interface with OpenStudio as a data model, which is really exciting. So that's if you use OpenStudio, there's a lot of doors that are opening there. OpenStudio with Python bindings, essentially. Modelica, this is a more kind of complex simulation framework that a lot of researchers use. And since I think even day one of the development of the Modelica Buildings Library at LBNL, they've been in parallel creating a Python package called Buildings Py, which really allows you to do a lot of the operational creation of models and simulations and things. So since day one, they've been making it possible to use Python to use on Modelica. Some of the proprietary software out there that I've been able to find, Design Builder supports scripting in general, Python being one of those scripting tools. You can use it to automate certain parts of the simulation process. You can use it to pre and post process the files and post process the time series data coming out the other side. I haven't used this, but I've kind of done some investigation, and it seems like it's something a lot of people are using. You have ISVE, where you can also use Python scripting to interact with the data model inside of IES to analyze data, to pre and post process things, to create parametric simulations and lots of other tasks. Rhino and Grasshopper, this is kind of an environment which is becoming more popular in the simulation community, where you have a Rhino model and you're using Grasshopper to sort of interact with it and do various things. So Grasshopper has all kinds of capabilities to use Python to automate things and to post-process data and all kinds of things. So if you use that tool, then check out some of the links there. There's a whole suite of tools that kind of fit into Rhino and Grasshopper called Ladybug. And you can check out the website if you want to learn more. Here's kind of a diagram on their website, which shows the different tools called Ladybug, Butterfly, Honeybee, Dragonfly. And they're all sort of like connecting into these different simulation engines, creating different types of visualizations, looking at everything from renewables to daylighting to energy to you name it, CFD. And these tools are open source and they're written in Python even. So Python really forms the foundation for these tools. And if you learn Python, you can actually even go in and get a sense of how these tools work. And of course, build your own Python components to pre and post process data coming in and out of these tools. And last but not least, if you're looking at urban scale modeling, there's a platform called the City Energy Analyst. This is an open source toolkit that is also written in Python. One of my former colleagues, Jimeno Fonseca, when we did our PhDs together at ETH, he came in my office one day and said, I want to build an urban simulation tool. What should I use? And I said, you should use Python. So that's what he did. And so lots of people are now using it. It has a plugin to ArcGIS, and there's basically simplified energy models at the urban scale that you can create to do network systems optimization for district cooling, district heating, things like that. So hopefully my Python evangelism has already started, maybe even a few years ago, to get people in this direction as well. So, what I want to talk about now is how do you go down these paths? So of course you can take some of my, you take the online course that I have, you can take lots of other Python courses that are out there. But I think one of the best ways to learn is to see examples of analysis, or what you might call recipes of examples. And so this is really happening in other domains. And I'll show in a second some of those examples. But in the building industry, the building performance analysis industry, there's a few out there, and I'll show you some of them. But also today is also kind of a call for others to try to get into this platform and start uploading their own data sets and create kind of a community of people that are sharing analysis recipes for others to use and learn from. So I want to talk about, and the two platforms that I really see this happening a lot in are what's called a platform called GitHub and the Kaggle platform, which I mentioned before. So GitHub, if you're familiar, it's a place to basically park code and have it be a place that people can check that code out, make changes, and sort of request changes back into the main source code. It's a version control, if you've heard of that. It's really one of the biggest open source repositories. And of course, Kaggle, I mentioned before, and we'll talk about in the next few slides. And a really good, I think, example of a lot of crowdsourced building performance data activity is a Kaggle machine learning competition that was hosted a couple of years ago, or basically the end of 2019, so about a year and a half ago, which was machine learning driven meter prediction, so meter regression. So there was a certain amount of training data given to the contestants. They were asked to predict test data on this platform using kind of this real-time leaderboard. And I'll show here in a second. But the cool part is that there was lots of data. So over 2,300 meters from almost 1,500 buildings across North America and Europe. And really the goal of this competition was to, have a whole bunch of people applying their techniques to the same data set and a relatively large data set, so that there can be this kind of comparison and benchmarking of these machine learning techniques, in this case, across these data sets. So the competition itself, there was $25,000 of prize money that was put up by the ASHRAE organization for the prize winners. And each of the contestants in the competition were downloading this data set, making predictions and uploading them, and they could see in real time how their performance of their prediction was compared to other peers in the competition. You could upload up to 2 times a day your prediction and see how it can improve over time. So check out Kaggle's competitions if you're interested, because it's very interesting how it works. And it was great with that kind of prize money dangling in front of people. We had lots of people participate, over 4,300 people across the world, and they collectively submitted almost 40,000 total predictions in the competition. The top winning teams, you can see the top winning 5 teams here, came from all over the world. A lot of them were machine learning and data science experts, and in their own sort of background and career. But a few of them, in fact, the winning team, one of the members of the winning team had a background in meter data and engineering. So thus bringing in that lessons learned of sort of expert knowledge also being important. And I'll talk about that in a second. So really this is the example I want to bring up is now we have the solution. So the top 5 winning teams were required to open source their solutions. We have those solutions on the GitHub platform, as well as they've also, a lot of them have shared their Kaggle kernels or notebooks. And then also there's tons of videos. Each of the teams has 2 or 3 videos where they explain what they did and how they did it. They've given instructions, detailed instructions on how to reproduce their solutions. Lots of really good stuff there, although quite complex, as you would imagine. A solution to win a competition like this would be quite complex, but it's out there nonetheless, and there's a lot of documentation to show how to use it. If any of you are a little bit familiar with machine learning, just a few really cool takeaways was that gradient boosting trees were really the best model. Pre-processing of data, removing outliers was really a big differentiator. And a lot of the winners, like I mentioned, have degrees or have backgrounds in engineering and have even worked on meter prediction in the past. So this is a little more advanced type of insight. But this next slide is the one that I think that I really wanted to bring up, is that a lot of the people that entered this competition were just getting started with Python. And so there was over 400 machine learning workflows on the Kaggle platform that were shared as part of this competition. A lot of them focused on starter code and beginner code. If you look here in the lower left-hand corner in this slide, starter code and beginner code was up to, looks like about 30 to 40%. So people really just wrapping their heads around, what is a meter from a building? What does it mean? How do you visualize it? How do you make a line chart, bar chart, et cetera, et cetera. So it's really, this is the kind of stuff that, and you can see 96% of this content was Python. So it's really a huge tool that was used in this competition. So lots of good stuff to learn from that. So, here's an example of one of those workflows. This is the most popular one. You can see it got over 800, if you look up here, 857 votes. People can upvote each other's solutions or workflows. And this one had almost 850 votes of people saying it was very useful for them. It showed people how to take the files, analyze them, open them, visualize them, do all these things. You can click on this to kind of see what that looks like. But this is really the future of, I think, learning how to do things, is you find an example of something that you want to do, and you basically use that as an inspiration, or even just simply copy it. You can see on Kaggle up in your upper right-hand corner, you can copy this kernel or copy this notebook. You can add your own data or switch out the data, switch out the visualizations, whatever you want to do. It's all about taking what has been done and adapting it for your needs, which is really the best way to learn. The data set itself is open source now, called the Building Data Genome 2 project. So all of these different meters plus a few more were added. You can find those online. You can download that data set as well and learn from it as well. And so beyond just that data set, we're also, I'm helping to lead an effort in what's called the IEA Annex 81, which is data-driven buildings, to curate and create and add more and more data sets. And now on Kaggle, I've got these 9 data sets set up already. A few of them are mine. A few of them are other open data sets that I found on the internet. That we give attribution to the creators. We put them on Kaggle, and we basically create more of these notebooks and these examples to analyze these data sets for various uses. And so this whole environment, we call it the data-driven development sandbox, has Kaggle data sets. It has data-focused tasks. We can actually say, using this data set, we would love to see if somebody could understand how these two variables are correlated or these things like that. And then people can actually make submissions. So we're actually creating potentially some hackathons, maybe some competitions that are more qualitative, where people submit their solutions. And really, all of this effort is meant to create content that others who are interested in learning can come and see and learn from and copy and try to adapt for their own needs. So, do you have a data set to share? If you have any simulation, BMS, EMS, BIM models, whatever, things that you could share to help with this, if this is part of your learning journey even, that would be great. Here is a link, bit.ly/donate-building-data, or of course you can send me an email, which I'll post at the end of the slide deck. So please let me know if you're interested in this effort. Even if you've never coded in Python, you can still possibly use a data set to learn from. Okay, let's lead into the final point. This is the most important point. I've saved the best for last. This point is all about how to get motivation and maintain that motivation to learn this stuff. This is really the most important thing, because as I mentioned before, the downside of learning to code is that it is a process. It can be a lifelong process. So how can a person, I know a lot of you are sitting there thinking, well, I'd love to do this, but I don't have time. How should I make time to do this? I have 20 things to do. Clayton, why do you want me to add another to my list? Well, let me explain what I think needs to happen is by explaining my own process. So why am I here kind of, yelling at my computer at midnight about Python? It's because when I first got started, I stumbled across it because I had various situations. One of those situations was I was on a model calibration project about 11 years ago. The building I wanted to calibrate a model for, I needed meter data. And the energy management system vendor didn't really want to share the data with me, I think. They said that only their system exports files as PDFs. So they can only send me these PDFs, and every PDF had timestamp and energy meter. So I basically thought, how can I get into this PDF and how can I use that data and pull it out and actually do what I need to do? So I found a Python library that allowed me to crack into those PDFs, pull out the data, and actually do the job that I needed to do. About a year later, I was working on another project where a building owner gave me this massive database backup of their BMS, all this time series data that I wanted to pull out and play around with and analyze and visualize. But it was 20 gigabytes. It was literally this file that would crash my computer if I tried to open it with Excel, obviously. So this is where I learned about Pandas. This is where I learned about how Pandas can sort of chunk apart these big files and do all these cool things. And that's how I cracked into that data set. And then a few months later, I wanted to model VRV systems in Energy Plus. I needed to regress my own curves for the equipment that I was using. And Excel was just frustrating the heck out of me. So I eventually figured out how to do this in Python, and it didn't take much. It was only about 15 lines of code, and it basically saved my life in that situation. So the key point is find problems that you care about, find data sets that are scary, find, I don't know, whatever you can find in your career, your courses, whatever, and use that data to try to reach a real objective that you care about. So you can use the tutorials, you can use my online course to get started, but you got to use real data and really caring about the solution to a problem is important. And every time you solve a problem bit by bit, you start to feel more and more like I say freaking superhero here, because it's really how you build motivation when you learn these things is tackling problems and figuring out how to solve them using Python. So with that, I'd like to acknowledge a lot of people who helped over the years and funding sources, of course. And so if you're a big shout out and thanks to all those people. And with that, I will take any questions. And of course, you can download the presentation through the QR code or link that's listed here. So I think we should have about 15 minutes left for questions.
Yeah, thank you very much, Clayton. Yeah, we do have a few questions. And for those of you who haven't asked questions yet, put them into the chat in Zoom, or if you are watching via YouTube, put them into the chat on YouTube and we'll monitor both of those. There's a question from YouTube from Van Long Lei. For Python machine learning library, should we consider PyTorch, Keras, or TensorFlow? And what is the advantage of sci-kit learn compared to these libraries?
Great question. Great question. So one of the challenges of using Python or programming languages like that is that there is a lot of options out there. So with machine learning, especially, there's tons of these different options, and it depends on what phase you're at in your learning. If you're just getting started with Python, let's say you're just getting into the machine learning landscape, I highly recommend starting with sci-kit learn. Starting with really, there's a, my brain fails me now. There's kind of a philosophy. I forget the person who came up with it, but it's you really want to start simple. I don't know if that's a person or whatever, but you want to start simple. You want to use the simplest model possible to achieve what you want to achieve. So I always suggest people to start with sci-kit learn, start with a really basic modeling technique. There's a lot of these tree-based models like gradient boosting trees and random forests that I think are good for beginners. And then once you've grasped that, once you've been able to do whatever application you're trying to do using these basic models, then you start adding and peppering in these more complex deep learning techniques, maybe, all like Keras and PyTorch, Keras and TensorFlow are very much focused on deep learning neural networks that are really, really good for image and computer vision. In the Great Energy Predictor competition, we showed pretty handily that nobody wants to use them for that type of data or that application. The tree-based models do a better job for various reasons. But if you ever dive into these more advanced techniques, and once you go down the rabbit hole of machine learning, you learn that there's a lot that goes into this. It's all about setting up sort of experiments. Okay, model type 1 through 10, which one works better? Model type 10 works better. Okay, now you go down that path further. So start simple, work into these other libraries like Keras and TensorFlow. I don't use deep learning very much, to be honest. I haven't found an application yet that really needs it. Of course, I haven't done a lot of computer vision stuff. I know people in computer vision that is like the number one toolkit they use. Anyway, that's a long response, but start simple. That's the main takeaway.
Yeah. So another question. I'm interested in the application of these tools in the nuclear and radiochemistry industry. Can you add your own constraints?
Yeah, I mean, that's one of the benefits I brought up before about using programming in general, is that it's by far the most flexible way of doing data analysis or simulation or anything. And I think Oliver mentioned in the beginning, like when simulation first got started, people were really building things from the ground up, like building. I mean, that's how Energy Plus was created. Basically, was people kind of just building it in a programming language. So you can add your own constraints for sure. That, I mean, I'm making a very long answer to a very short, could be a very short answer. So whatever your context is, using Python, you can really build things from scratch. I would, though, however, would recommend, I'm not familiar with nuclear and radiochemistry industries. I would recommend seeing what has already been done that's already out there. So engines or environments or packages, libraries, Python libraries that are in those areas, start there. Don't start from scratch, because they'll probably have already built something which is fine-tuned for that area. And literally every time I don't know something, I just Google Python radiochemistry industry, and I usually find very quickly all the packages, all the libraries that are out there. And you can do that. You can repeat this for anything. Oh, I want to start doing computer vision to detect, people walking by, whether they have long sleeves on, therefore we need to turn up the thermostat. You can literally kind of Google these things and find these libraries and piece together a solution using something like Python, which is really fun. But there's lots of potential out there. So
another question, and maybe it's related to that answer. How is it possible to define an occupant behavior model, like a logistic regression or a deep neural network, to model the occupants while simulation of Energy Plus using Python?
Yeah, so this kind of goes into the depths of using like more advanced modeling workflows, where, like, let's say with Energy Plus, you want to have these really fancy occupant behavior profiles. Like you want to be able to make them dynamic, or you want them to be able to respond as the simulation is running. You want to be able to update the inputs for that. That's really where the Energy Plus Python API is going to come in really handy for people who want to do stuff like that, where you can actually have some sort of like engine. Maybe you have an agent-based model running over here. Maybe you want to insert, dynamic occupancy profiles into the simulation as it runs. Basically Python can be used as a glue to glue these kind of things together. So in simulation, especially in research, people talk a lot about coupling engines and doing all these fancy things. So Python is really sometimes the glue which allows these things to basically work together. And that's becoming more and more common. So it's, the sky is the limit. There's a lot of, like I mentioned before, flexibility is definitely there, which sometimes is a hard thing because you have to make decisions because you're not limited by the language. You're limited by your time and which rabbit hole you should go down, basically. But hopefully that was useful to your question.
Right. So Eddie asks, how much do you think regular AEC professionals should know programming? Yeah. Should we leave it to the specialists? Noting that most of the ASHRAE winners are data scientists and not, MEP engineers.
That is an excellent question. That is an amazing question, because everybody's going to be different. So I mentioned some of my story. I highly recommend even just the most disinterested MEP engineers to learn scripts which can help them automate certain parts of their overall job. So I guarantee you'll never automate your entire job using Python. So you take little parts of like what I did. I had these little problems I wanted to tackle. You're going to use Python in the early phases to do that. And then the person might say, wow, I really love this. And they really learn more and more and more and more. And you get to the point in your career where your trajectory goes into developing software, perhaps. And so it comes down to the person. It comes down to your own, do you hate programming? If you do, you probably will only do it for basic things. If you love it, you're going to maybe end up being a software developer. And I've seen people unfortunately get pulled out of the building industry because they get skill levels high enough that they end up getting pulled into these other startups and these other industries and making huge amounts of money as a data scientist and, in Silicon Valley and stuff. So, but hopefully we can get enough people that our industry starts creating these type of opportunities and these data scientist jobs so if somebody really gets a lot of momentum, they can really make it into a career. But to go back to the question, how much should your average AEC professional learn? I think you should definitely learn enough to automate frustrating manual processes that are a waste of time. So just at the very least, you should try to do that. Or maybe if in your colleagues, you become the best Python person, maybe you can do some of that for your team or something. But it ultimately really, it depends on the person. I mean, that's another trying to make the shortest answer possibly.
All right, thanks. So how about, what are your thoughts on how data science helps in understanding indoor environmental quality? We always talk about building energy. And so how about IEQ?
Yeah, so IEQ is data from IEQ systems is really exploding. I mean, you see lots of, sorry, my screen flickered. You see lots of solutions on the market. You see a lot of building owners now investing in what's called IoT. Okay, so what is IoT versus BMS? BMS is really controlling the building, whereas IoT is actually being installed just to create data. And so here at NUS, for example, we have these IEQ sensors being installed sometimes at a density of one device every few meters, like in a grid pattern. So you're ending up with even dozens of these sensors in the same big zone. So the ability to process those time series data using something like Python is becoming even more important because, of course, all these solutions have their dashboards, of course, that you can see all the data. But to take it a step further and actually collect all the data, merge it in with the BMS data, try to create a scatter plot of different sources, add weather data, add this, add that. These are ad hoc analysis processes that you're going to need something like Python, or of course you could probably use Power BI and Tableau and some of these other tools. But so to go back to your question, the more people that have these skills to process these large data sets, merge, process, and visualize and make decisions and create visualizations for decision makers, the better that we're going to be able to leverage all of these devices being installed. I mean, I think that's the only way. You're never going to use spreadsheets. We can't rely on that. So, yeah, because one of the key things about Python and learning these techniques is distilling lots and lots of raw data into a fairly easy signal for humans to understand. And really, that's when I talk about processing and visualizing, that's what your goal is. You never even touch machine learning most of the time when you first get started with Python. You don't need it. You basically just need to take tons of raw data and make it into something that a decision maker would be able to learn, to make a decision better from. So yeah. So all of you out there thinking, oh, I got to dive into machine learning right away. No, take a step back, look at some raw data, look at just how you can visualize it. And really that's powerful enough for the first, I don't know, 3 or 4 projects you do or more. So, yep.
Great. So here's kind of a specific application question. So I'm trying to find an agent-based model, module/package to predict user behavior using Python. Do you have any guidance on that?
I don't, off the top of my head, I don't, but I do. There is a postdoc researcher on my team that just started with us actually recently, and that's what he's going to be doing, is going down that path. And just through the discussions I've had with him over the last month or so, I think that there are some, if you literally just Google like Python agent-based models, there are already some libraries and frameworks that people use to create agent-based models for other applications like marketing and biology and all these things. So just through the basic discussions I've had with this postdoc, he's already gone down that path and he's using CEA, which is the urban scale energy modeling tool I mentioned before. He's planning to use like agent-based models to create these occupancy profiles that are more diverse, and you can kind of like create the different agent characteristics and things. So I don't have any specifics, but I know that it is something cool, and I'm strongly guessing that there are already some Python momentum out there. Sorry, I don't have a specific package I can suggest.
All right, so we have maybe a couple more minutes for a couple questions. Here's one. By the way, thanks for a great presentation. Many people are giving great feedback. Thank you, Clayton. Any resources to recommend to learn about strategies to cure issues with sensor calibration and other building specific data issues?
Yeah, so going back to the suggestion I just made about visualization of data. So let's say, for example, you've got 1,000 CO2 sensors, and everybody knows that CO2 sensors in real buildings eventually fall out of, like, they kind of drift, or they're not great at maintaining their levels. If you take 1,000 CO2 sensors from a single building, and you plot them all together, which you can do using Python very easily, you can quickly see the ones that are going off in la la land, right? That are drifting off and all these things. And you can make little experiments. You say, okay, on the weekend, the CO2 sensors should all kind of like probably be close to ambient because blah, blah, blah. You can quickly create these visualizations, which really show very fast which are the ones that are okay, which are the ones that need to be calibrated, what kind of offsets can you add. So I find that 80% of the value that I've accomplished using Python since I started using it is mostly processing data, visualizing it, and a human being looking at that and saying, oh, this is okay, this is interesting. Oh, okay. Not hardcore machine learning, not models, doing all kinds of magic or anything like that. So, yeah, hopefully, yeah.
Yeah, thanks. Yeah, it strikes me that using this kind of visualization capability for energy models can help with sort of quality control on our models too, as well as our sensors in our buildings.
Exactly.
So yeah, just another minute. Does your course cover this material as well? I assume we're talking about the edX course here.
Yeah. So the edX course really starts from the basics. So if you've never coded before, it starts with Python, and then Pandas, and then visualization, and then time series data, and then finally machine learning, introduction to machine learning. So it runs pretty fast, and it dives into applications very, very quickly. But at the end of the course, we don't dive much into machine learning. So we really focus on loading data, visualizing it, the basics in a sense. So I recommend, just to get started, if you already have a foundation in programming or Python, it might be better to go into some other more generic machine learning edX courses. There's dozens and dozens of edX courses. I am working on another layer onto the edX course, which will dive into more advanced machine learning stuff, but that won't be available until probably end of next year. So working on it now, in fact. So
great. And perhaps one more question here. I know you've touched on this in a couple different ways, but what are some of the most impactful project areas an AEC professional can apply data science and programming to?
Yeah, I think just in the context of like IBIPSA and building simulation, building performance simulation, I think the low-hanging fruit for an impactful reason to learn programming for that type of person is, well, there's two projects. There's input file manipulation and creation. So if you're using, like, for example, Energy Plus, you can really make parametric analyses very quick using like automation using Python. So that's something that a lot of people get started with, and it's very useful depending on what you're trying to do. But even more, I think, valuable is in simulation, taking the outputs of simulation and merging those data with other things and kind of merging and visualizing. So, I mean, if you're just getting started, you could literally take some of your old projects, data sets, load them, merge them, visualize them. And that in and of itself will probably be really interesting to your colleagues. If you all have never done this before, you'll see their data in different ways than what the conventional tools show you, as well as, something like Excel or even Tableau or these others. So that is a very impactful first step, let's say, for simulation experts out there. That's kind of how I also got started, like just playing around with existing data sets and seeing what I can find that this tools wouldn't already show me, basically.
All right. Well, thank you very much to Clayton Miller, and thank you to everybody who's joined in this webinar. It's one of the most popular ones IBIPS USA Education Committee has held to date. So great job. I'll say once again, for those of you who aren't IBIPS USA members yet, consider becoming a member to support programs like this. You can go to ibpsa.us and you'll find the information there about becoming a member. I also want to note a couple other upcoming webinars. The IBIPS USA Research Committee has one on end-use load profiles for the US building stock coming up on July 29th. And then the next Education Committee webinar is on QA and QC for energy modeling, which will be an interesting panel discussion on different approaches to quality assurance and quality control for your energy models. And that's August 18th, and then September 30th, there'll be another webinar on IBIPSA Project 1, New Generation Computing Tools for Building and District Energy Systems on September 30th. So thank you everybody for attending, and that will be the end of our webinar.